our robot a condition. We want to give it a condition in such a way that it will move until a certain time period. We are going to use a time period. So for us to use a time period first, we need to be able now to set we need to be able to set our brain so that it can be able to explain it can be able now to tell if the sensor is either if the robot has moved to a certain period of time. So we're going to set the brain time. So we're going to drop it down here. Without this one, our code will not work because our robot will not be able to interpret these. Nisawa. So now we want to add a condition. So our robot will be following a condition where we'll be using time as our variable. So when you go to time in seconds, so we want to do this. We want our robot to move at a particular time. So we want it to move. Let's say it's supposed to go for about 48 seconds to be able now to stop or do something else and stop following the line. So what it will do is this: we come to operators and give it a condition of or will so with or will is either we use is equal and is equals and greater than. Is it greater than? Yeah, greater than. So hello, Free, are we together? So we are going to use these two conditions. Uh, we are going to use we are going to use both is equals and greater than, so that our robot can be able now to give it a variable of its own. So time so we're giving it a condition where time will be greater than or is equals to put it there. Are we together? So now we have given it a condition where our robot will be able to move at a certain time where now our robot will be following the line until this time elapses. After the time elapses, for here I've just let me just put something like 45 to 45. Then after it has followed the line that way, it has now to stop. So we stop the left motor and stop the right motor. So with this simple code, do you do Priyata, do you have your robot with you? Priyata, hello. Uh, can you do you have your robot with you? Like right now, do you have your robot with you? Okay, can you be able to test this code? Okay, just try this code. You upload it, then you put it on a black line. You see how it will be, how it will respond. Okay. Okay, it's okay. It's okay. If possible, can they be able now to follow up with this after we finish the session? It's okay. So I go. I just finished the whole process. Okay. So then, so with this code now, the code that I've already written here, the robot can be able to follow the line, but now it will be swaying, right? Like the way the one that you saw with Changamwe, it was swaying, right? That means it's looking for the black line. So when it sees the white line, it goes to the left, and it sees the black line. So it uses that momentum to be able now to be able to follow the line correctly because it only has one sensor. So and again, uh, when I was talking to Malimu of Changamwe, she told me that the problem that they are having is time because it cannot be able to move at a very high velocity. You cannot change this velocity to maybe 60 or 100. It will not be able to follow it smoothly. So to curb that situation now, the purpose the purpose of our robot is to be able to complete the missions, right? And also to be able now to do those missions at a faster rate, and also to be able to complete them at a very well, and also the way it's required to, right? So with this with this simple code now, we can now be able now to manipulate it in such a way that it can work at our advantage. Okay. Let me see if I can be able to open the mat. Can you be able to see the mat? Hello.
Yes. Yes.
Can you be able to see the mat
Yes, you can see
that
the
I'm
maths.
presenting? Okay. So the first mission is supposed to start from the start point and deliver it to C3 and goes to reset, right?
Yes.
So you can give me an idea on how we can be able now to solve the problem of we can be able now to use the optical, and at the same time we don't use the optical, so that because when you're using the optical from the start point, maybe you can use the optical maybe to turn. After it has reached this point, it moves straight. And when it reaches this point, now it's also, you turn on the optical, now it follows this line to here. After it has reached here, now you switch off the optical and it moves straight to C3. Can that be able to work?
Yes.
Yes.
So after doing that, now it reverse, and maybe you turn on the optical, it follows this line. Turn off the optical because the optical cannot be able to follow this with this dotted. After you have turned them off, now it moves straight to reset. Is that possible?
Yes, it is possible.
Okay, so let's go back to our code. Now, how can we be able to do that? There's a trick that I shared with the students from Changamwe, where I use define. Do you know how to use my blocks? Students
Yes.
from, do you know how to use my blocks?
Yes.
Yeah. So because you are using left motor and right motor, and with this code, it can only follow a line, and it cannot be able now to move straight without the optical. So now let me write another code for it to be able to follow a line. For it to be able to move straight, it's like we're using drivetrain. So the first thing is we set the velocity of the left motor and the right motor. After that, we set it to spin forward. Then we are going now to give it a condition to move forward at a certain time before it stops. Stop left motor and stop right motor. So when you upload this code, where is the code started? When you upload this code, the motor will, the robot will move forward for 1 second. So we are using time as our variable. Okay, we are using
Yes.
it to be able to determine how long our robot will be moving forward. Yes, sir.
Yes.
So now, because we can't keep repeating this statement over and over, now we are going to put it under my blocks. So when you come to my blocks, make a block. Let's say we are saying spin for block name. Spin for input. The first one, input. The first one we have, let's say time, and we label it as seconds. Then we have the second one as the speed one, which is for the left motor. So let's say L speed. Then we have L speed. Then we have labeled it. Then the second one, we have the right speed. And then we label it.
Right speed.
Then, okay. So we're going to drag time down here. Our left speed, let's put it there. And then we have
With the person maybe like I can display pictures, service to try to show the picture of the act.
So now we have already defined this variable. Are we together there, Priyatam?
Yes, we're together.
I'm going very fast.
Never way that you best way for you to
Okay, if there's anywhere you're not getting what I'm saying, you just say yes or no. So now we have now
machine that farmers like yourself. It's the best of them like farmers to it and make it better for them. I hope I understand it, but you know, so okay, thank you.
so we have already defined that we want our robot to spin forward, right?
Yes.
So it's going to spin for, let's say this is the first thing because it's starting from the red line here. It's starting
Yes.
from here. Now she's
Yes.
supposed to move a little bit in front to be able to make this curve, to be able to follow the line if you are using it. So let's say here it's moving for 1 second and speed of the left motor, let's say you have used 60 and 60. So when you write that code, our robot will be moving forward for 1 second. After moving for 1 second, it will now start following the line. Are we together?
Yes.
Okay, that's another concept you can use. Then, if let's say you don't want to use the optical sensor for maybe this point, for maybe you don't want to use this for people who maybe decide let's not use the optical sensor because of time. Because I know most of the thing that is inconvenience is time to be able to complete this vex a little bit slow. So to be able to do that is this. We want our robot to move with a curve, a smooth curve from here to here, following a smooth curve, then coming here and making a smooth curve to shift through. Let's assume all this other code. Let it not confuse you. So we are using this. Let's assume we are not using the optical right now. Let's place it over there. We are only using define. So using define now, we can be able now to work with left motor and right motor. Sometimes it promotes a very smooth turning. So go to now you only use this by block.
But you need to make a case for required yourself.
Students from here, do you know how can we be able to make it to move to turn?
No.
Yeah.
No. we don't know.
How can we be able to use this code to make our robot to turn? Maybe to turn to the right.
You make the
We reduce the speed on the right side and then we increase the speed on the left side.
Yeah. So that's the way we can use it to be able to make a smooth turn. For example, you want it to make a very smooth turn for like 1.5 seconds. Let's say for 1.5 seconds, you want it to make this turn. This one, this small turn. So we come and add, let's say the first one, let's say 60, and we put the right motor to 40. So you can take this code and now you can be able now to adjust the value so that it can be able now to make a perfect turn. Or if you want it to make, let's say, a 90 degrees turn, you can also put maybe this on 0. And you now you moderate it with time. For example, you can say 0.5. If it doesn't turn 90 for 0.5, then you continue adjusting the time. Are we together?
Yes.
Umenipata hadi pale?
Yes.
Any question? Any question? Mostly I want people from Freetown to wanauliza swali. Since I met up nilikutana na watu wa Changamwe, and I think they understand how to use to be able to work with it. Yeah?
Yes.
Yes.
Are you comfortable?
Yeah. Yeah. We're comfortable.
Okay, so I think I've gone through everything on how you can be able to use line following, and also you can also be able now to use how you can be able to use the left and the right motor. So most of the time when you're using left and right motor, uh, I always advise to put all this under define. It makes work easier. Instead of repeating this code over and over again, you can put it under define and have only a simple code. Ni sawa? Tumepatana hadi pale?
Yes.
So I want now I want people from Changamwe, not Changamwe, people from Freetown, at least tell me how can you be able now to accomplish the first mission? How
Pardon?
how how, how do you want to accomplish your first mission?
Pardon, please.
You can't hear me. Okay,
Yeah.
how can you be able to accomplish the first mission?
How can we complete the first mission?
Yeah.
The
Which way
idea that
which way do you want to use?
the idea that I had in mind
Yeah.
was using both hard coding and line following,
Okay.
where we use line following from start, it takes the
Yeah.
curve, and then from
Okay.
the intersection V1 up to the end of the line, we use hard coding for it to go
Okay.
straight, and then from there it
Yeah.
starts by using the code.
Yeah. And are you sure it can be able to complete it at a very little time possible?
Yes, because when you're using line following,
Yeah.
the amount of time the amount of the speed, the velocity you need is little, but when using hard coding,
Yeah.
the velocity is faster.
Okay. So that one can be able now to help you.
Yes.
I'm sure most of you when you went for the competition you are discouraged because the other robot was using 3 sensor. That's another model. It's like you are riding a Mercedes and someone else is riding which car is a little bit different. A Subaru. Can that be compared?
No.
A Mercedes and a Subaru? No.
No.
Which car can be compared to a Mercedes? And it's a different model.
Comparing
So
a Maybach
what
and a
matters?
Mercedes.
Yeah. So what matters uh, is it able to complete the mission? Is it able to make you travel from one point to another? Is it able to do that?
Yes.
That's what matters, right? It
Yes.
doesn't matter how many sensors you have, how many sensors, it always determine now who is better at coding. Now, that's where it comes down to. who knows how to code. And I've heard you guys are good at coding, so show the difference. Many get.
Yes.
Yeah, so it's just a matter of knowing how exactly, this competition. There's only one trick people always use. Don't follow the rules, but follow the rules. Many get like
Yes.
follow kuwa mjanja. Like the best thing ni kuwa mjanja. You I have another thing is, can you be able to work like this? For example, Freetown, are you going for regionals?
Yes, you are going for regionals.
Okay, so let's say but sir, now I'm talking to you, both guys are competitors, so I think you just have to, anyone who will be now clever enough to be able to do this mission will be able now to accomplish it and become number one. So when you go to the regionals, I'm sure you'll find a lot of people will be able now to accomplish all the mission. Everybody will be accomplishing the mission at the same time, or either they complete the mission at the same time, or maybe all of them accomplish the mission. Like everybody is able to accomplish the mission. So what will be the difference between you and the other team? Nissan.
Innovation.
So what will yeah. So it's all about who is better. Because you'll find that most of the teams, maybe you have the same mark, you have completed the mission almost at the same time, you see. So to be able now to do that is now you have to come up with a simple way on how we can be able now to handle this. Tunasema tuseme robot tunaweza combine the mission. It's possible to combine the mission. Let's say
Yes.
you have combined your robot to start from the start point. It's supposed to go and to P3, and the second mission is supposed to pick from D2. It's supposed to pick from D2, or it's supposed to pick from B1, or it's supposed to pick from B1 to A3, right?
Yes.
So, how about this? If we can come up with a solution where you combine both missions, by which you can say it starts from the start point, right? So when it starts from the start point, it goes and picks. It starts with mission 2. It picks from B1, goes direct to A3. After going to A3, it goes back to reset. After going back to reset, it goes and pick the object from C1, the one that is delivering from C3. Because according to the marking scheme, they didn't specialize that. Like hawakusema ati robot lazima ichukue object from the start point. The only thing they said was it needs to deliver to C3, right? So after it's from reset, it goes, pick it from C1, then go to C3 and goes back to reset. Have you gotten the idea?
Yes.
So you have combined two missions and you have done the two missions at once. Is that workable? So I want you guys to do this. Come up with a solution on how you can be able to combine the mission. Then and don't do this. Have all the code for the one that they say you have to come back to the start point and deliver it. And the next thing is to do them at once. Nisawa.
Yes.
So have those two codes as a second option. So when you go for the competition, you just go and ask the judges if it's possible to combine both mission 1 and mission 2 at once. Nisawa.
Okay.
Yeah. So that I'm doing this because it will act as a disadvantage. It will act as an advantage teams, all of the teams that will be there will be doing the same thing, going to the reset, going, delivering, going to reset to the start point. Because every team that's going to the regionals, that means they are good at what they are doing. Is that okay?
Yes.
So how can you be clever? It's just a matter of being clever. In robotics, it's just a matter of you being clever. Because everybody will be doing the same thing. And also, for those you will even find some teams where they're not even using any sensor and they are completing the missions very well. Mhm. So I don't know. Let me just a minute. Let me just show you a small video here. Okay, just a minute. Any question? Any question?
I was asking
Yes.
if instead of using the left motor and the right motor, you use drivetrain.
So for the drivetrain, I actually tried using the drivetrain, and it doesn't work very effective as the left motor. When you're using the drivetrain, when you're using a drivetrain, you have limited yourself to, it cannot be able now to move at a steady nini. But you can do your research. For me, I actually tried doing my research. I tried using the drivetrain, and it kind of know why, but you can try. You can give it a try. Everything in robotic you learn, but if it doesn't work, you can use the left motor and the right motor. Is that okay?
Yes.
Yeah, you can give it a try. Maybe you can decide changing, instead of using the left motor, use the drivetrain.
Yeah.
It's how. When are you going for the regionals? Hello.
Yes.
When are you going for the regionals?
Uh, is it on Tuesday?
Hmm?
Is it on Tuesday? Wednesday. Wednesday.
Next week.
We are traveling on Tuesday next week, and the regionals is beginning on Wednesday, Thursday, and Friday.
It's okay. By any chance, I'll be there if possible. That is, I'll be coming and checking on your progress.
Okay, thank you.
Any other question? Any other question? Any other question?
In case we have a challenge in our code,
Yeah.
can we seek for assistance during the competition?
During the competition.
Not like during the competition. In case you're having a code with a, we are having a challenge with the code for the competition right now while we are trying an error.
It's okay.
Can we ask for assistance from you?
Yeah, it's possible.
Okay, thanks.
Can you be able to see my screen?
Yes, you can.
I'm sharing with my phone. So these are students. They're using a different type of robot, but they are not using a sensor. See how it's working? They're using the left motor and the right motor to code this. So they have combined the both missions.
Is it using light sensor?
No, it's not using any sensor. Let me run it again.
You see,
See the way.
one of the judges, who was actually judging us,
Yeah.
talked of
Yes.
when we go for the regionals competition, the
Yes.
Semastia judges, might actually
Yeah.
disqualify us for not using light sensors. That is what he was saying.
No. No. Where is that rule from? Okay, that's an assumption that people are coming up with, and it's going to affect a lot of people. Okay, for example, there. Okay, what he was trying to explain is it's not a must that you use a line follower. The only thing is the robot has to accomplish the mission and follow the line correctly, right?
Yeah.
Yes.
And see the way this robot is operating. If you are a judge, will you penalize these students because they haven't used a sensor?
No.
See, it's following the line,
Yes.
Yes.
yeah, and they're not using any sensor. So will you penalize them because they haven't used a life sensor? Is that
No.
even valid? So, well, actually, the only thing I think they were saying is this, that the robot at least need to show that you have incorporated at least some sensor in it. Okay, so for example, maybe they will say these students didn't incorporate any sensor, so they don't have the mark for the sensors. Okay, because when you go to the part where they are talking about the audible part,
Autonomous.
that's where they are talking about sensors, right?
Yes.
So, for example, if maybe these students decide that from the start they are going to use a sensor, in which their sensor will be their trigger to start the robot. They have used the sensor, or they haven't used the sensor. So it's
They
not
have
it's
used
not
the sensor.
there's this assumption that it's going around that you're supposed to use a sensor. It's not a must, and that assumption is the assumption that most people are panicking, and they're like, no, we can't be able to code using the sensor, and so the only thing that matter is your robot able to accomplish those missions. So if for example they ask which sensor have you used, you can just this for the clever people, maybe you can maybe use the touch sensor as your starter, or maybe you can decide that I use maybe a distance sensor. When it reaches the object, it's able to sense a distance sensor. Is that right? So you can incorporate it anywhere you want.
So
But
you
the
can
main point is you'll use the sensors, yes, but has it completed the mission? Has
use
it
different
gone through
sensors.
point?
You can use
Yeah, you
different
can
sensors as
incorporate
long as it
different
completes the
sensors.
mission.
Yeah. So you can be clever. It's a matter of you being clever. It's not a matter. It's not a matter of you must. So don't sometimes in robotics you just have to use your own brains, because when you go for the competition, I'm sure everybody that will be there will be using the
Sensors.
line following, yeah, optical sensors. Everybody will be doing the same thing over and over. So how clever can you be? Come up with a solution. Is either use the optical sensor in one point, or use it the whole point and maybe add something else. Maybe you can use the touch sensor as your start point. So it's a matter of you making your robot more competitive than the other team. Is that okay?
Okay. And
Yeah. So no matter which type of yeah.
Okay, I had a question on using the distance sensor.
Yes.
Can you use this when you're hours you're using the Vex Code IQ where we created a Flowbot? Now I was asking if we can
Yes.
use the distance sensor to trigger the claw.
To trigger the flow.
Yes.
Yeah, it's possible. You can do that. Just you know how. You just have to know the mechanic you can use. Maybe you can decide to place it inside at a point where it can, when it sees an object, maybe it stops at a certain point and pick it and close and open. Yeah, it's possible.
Mm.
Okay, let me. Do you know how to code the distance sensor?
The distance sensor.
Yeah. So
No.
for because you're using second gen, don't use the first gen sensor. Use this one. Oh, I'm not sorry. Sorry. I was sharing my phone. I forgot. So so do you know how to code the distance sensor?
Well, I know how to input the distance sensor
Yeah.
and but I do not know how to code the distance sensor and I do not also know how to I do not understand the use of the distance sensor fully.
Okay, you do not understand this fully. Okay, do it very fast. Let me do this. I'll just use this same space. Let this not so for example, you have said you want to use it to open the claw. So let's go and add the claw. For example, I've added my to 9. So what I do is I'm going to change on top there and change it to claw. Okay.
Yes.
And another thing is you can change this forward also to open, as in just to have a different nini, have different variable than the one for then you have close.
Noise.
So we have added the claw, and also let's add the distance. So for the
Distance
distance sensor,
second
the
generation.
robot that you have is not, yeah, it's a second generation. So you select second gen. We have connected, let's say, to port number 11. So this is what we wanted to do. Uh, we want it to open the after maybe it has seen object, it opens the claw, right?
Yes.
So what condition are we going to give it? We are going to turn to distance sensor. Yeah. So we're going to use millimeters. Is that okay? Then we are going to use this variable that says wait until this one. Then I'll go to operators. So we want to use let's say We want, let's say, to be greater than, to be less than. So you can be able now to measure the distance from the optical to the distance from the optical, from the distance from the distance sensor to the object.
The
Let's
object.
say 5, right? So
Yes.
when started, our robot will wait until the distance is 5, and so this is just a simple code. Then it will be able now to spin either the claw. So we change it to the claw, to spin the claw open. Then that's done. That's just a simple code.
Okay.
Are we together?
Yes. So basically the
Have you
distance.
understood?
Yes, I've understood. So
Yeah,
basically the distance sensor senses objects in front.
yeah.
Okay.
It senses the object that is in front of it.
Okay. Thanks.
Okay. Any other question?
I don't have any other question.
So there's one last thing I wanted to show you on how to measure the intensity. I didn't go through it.
So you measure the intensity.
To measure the intensity of the black line.
Okay. Okay,
Let me
so our black
open.
line, the intensity is red 0 degrees.
Yeah.
Our black line with
No.
the lights
Okay. Let me.
with the lights off, it's 0 degrees red.
Yeah. Most of the time. Do you know how to measure the intensity?
Yes, using the robot itself.
Yeah.
Yes.
Do you know how to write that code?
No.
Okay. Let me just go through it very fast. Let me just use this first. So you can even screenshot this. So we have to set the optical. So we set the optical on, and also we set it to 100%. Always use 100%. Is that okay? Then put it in a forever loop. When you go to loops, you set the cursor. Then so let's say the cursor at 3 is where it's almost in the middle. Then you print. Let it print brightness. Brightness. Then
Wow, 14.
then
Wow, 14.
you go to operators, fencing. Then print. Supposed to print the percentage. So, you can screenshot this code so that you can use later. This code.
Okay, it's done.
Okay. So with this simple code now, when you put on the black line, it will tell you the brightness of the black line. So with that brightness of the black line now is the one that will come and use it here, here, here. So for example, because it always range, it has a range of about, it will give you either between 20 to around 70. So for example, if it's 70, use the highest. Maybe it's 70, you can just say 73. Is that okay?
Yes.
Or you can maybe say up to maybe 80, 75. Just give it that range.
So between 73 to 75.
Yeah, but if you measure, just measure yours.
Huh?
Maybe yours it will give you less. That okay?
Yes.
Any other question?
No.
You don't have a question,
Yes, I don't have a question.
but are you still discouraged?
Huh?
Do you feel discouraged that your robot doesn't have three senses?
Pardon, please, I did not hear.
Are you still discouraged that your robot doesn't have three sensors?
No, I'm not.
Don't be
You know,
discouraged, Bana.
the issue with my robot, I was actually panicking because of the judge. He said that if the line does not follow, if the robot does not use a sensor, it will, you might be disqualified. That's what was making me panic. But I had already done the hard coding for the robot and it was moving nicely.
Okay, so instead of you panicking, you can use any type of sensor you want, and you can use it instead of following the line. You can use it as a starter. For example, you can use the touch. Do you know the touch LED?
Yes.
Do you know how to code it?
Exactly. No.
So you can. It's very simple to code for the touch LED. You can use it as a starter, or maybe you can use it as a you can use
Stopper.
it to show different colors. You know, like you show it.
Okay, I know how to make the touch LED show different colors.
Okay, so you can even put that and say that that's a sensor that every time it senses something, be creative. It's just a matter of you being creative. So you just say at the moment it senses that it's supposed to turn, it turns red. Nani
Okay.
atakupinga? Yeah.
Yes.
So it's just a matter of using those sensors creatively. Is that okay?
Yes. Yes. Yes.
And we have a touch sensor there. You can also use the touch sensor somewhere. You see. So it's just a matter of you being creative. The moment you become creative, the moment you'll understand on how to use these things.
Okay. Thank you.
Also another thing I forgot to tell you is you can decide to do this. You can decide to put this line follower
Yes.
into define also, so that
Is it
you don't have to repeat it over and over again when you're. For example,
recorded?
you want to use a distance in a certain period. You don't have to repeat this code over and over. You can put it under define.
Okay.
Is that okay? And
Yes.
when you're putting this under define,
Yes.
you'll have to use this the first variable for if you have to use different meaning. But you'll just try it out and you'll explain it to me later. Is that okay?
Yeah. Okay.
Yeah, if you have any issue, you can just call me and I'll be able to guide you.
Okay. Thank you.
You're welcome.
That's true.
Is Malimo still there?
Malimu has left for the time being. He has another online meeting.
Oh, it's okay.
Okay.
So if you can just work on that, I
Yes.
hope you have mastered on how you can be able to code the line follower.
Yes.
Yeah, it's out. So if
Okay.
you have any other question, you'll just ask me.
Okay. Thank you, Mr. Haddington.
You're welcome.
and I appreciate for the guidance.
Thank you.
Thanks.
Have a great evening.
Same.